important in Grasshopper to just keep going back to the basics and being fairly playful with what you're doing. Um, in order to figure out each node and what it can do, it'll slowly like sink into your head. You'll find patterns and snippets, and you might make your own clusters to do that. This is a nice little thing that I keep using, the gene pool. I just love it as a tool, but I wanted to look at the set sequence tools and get into called index. We can go into call pattern, call nth, random reduce as well. Basically, I'm just applying it over here once in the script. And what I've done is very simply, again, which is the basis of almost everything I do, going to shaded, is I build a point system. And my point system should be around here somewhere. There it is. It's a system series of points that come out of a range. And I have basically had fun with growing that range through the sine, through the power of e, through the square root, just getting data. I jitter it, so the Z pattern, so it kind of staggers up in all different directions and becomes an interesting thing. And I could jitter around, but I like the shape that's being made right now. And then what I did was I decided to call the pattern with the gene pool. Now, with the gene pool, you're going to want to know your list length as you play, and you can always set your gene pool, which is a little manual, and some people won't like it, but I could set that to 64, but I'm going to leave it high at 121 because it's basically just building. It's selecting indices or not. To go through the list, and if they're not in it, well, they just won't pick it up. But it manipulates that list of points again into this bit and calls out points and makes a different series. Now, in making a different series, I can interpolate that into some wonderful curves. And you're like, well, what are those curves doing? Well, they're going all through a series into a direction of a revolve, and I end up with this multiple kind of crazy pot form of multi-layers that's all kind of revolved together as line. So it'd be very hard to do with a piece of paper, but it's very easy to simulate here. And then what I do is I just throw it into dividing the points and extruding those points in the form of amplified direction vector to the normals. And in doing so, I end up with all this series of really cool stuff. So here's one iteration of it as I turn it on, or at least I thought I would turn it on. I'm probably going to have to go to, yeah, there it is. And I've thrown it into, knowing that numbers are 16, I can always throw it into this little color algorithm that I have that makes for a pretty interesting script if you put your stuff over into rendered. So there you go. You're left with this kind of thing. It's not a slow-moving script. This is it. But a lot of overlapping of color. You'd have to remedy. I keep things separate for now. You'd have to remedy all the extrusions and close brackets 16. And you could do a Boolean union when you pull them into Rhino afterwards. But right now for visualization, I just leave them as that. And then what I'll do is I'll go in, and there's so many ways to play with this, but I think the easiest way is to just go in and do a random, we'll just do a random 10% on it. And you can see there, all these forms just like that just became that. And, you know, it's really about deciding, you know, what am I doing? Like, how is this purposeful, but for design, like another random 10%. There's another form as it shifts and goes through its decisions, makes another shape like this. Like, I really don't know how to emphasize how one would even, you know, the computer's building and conceiving and making patterns, and I haven't even changed anything but just a kind of tool that was used for optimization. I'm doing 100 times change now, and we're just waiting a few seconds for it to kind of process. And there you go. You get another form that's in there. Now, if you wanted to, you could take the solver off, and you could go in and say, listen, I didn't need that amplification. I didn't need that multiplication through a square root. I could use the jitter and pop it into something totally different through the jitter node, and we'll do that. And that's going to allow it to jitter in a much different way on the z-axis. It's going to let it have some real ups and downs. And as we wait for it to process, I mean, we're 4 minutes into this little tutorial. The script will be online, and we've got some real problems with shapes going a little too chaotic. And what's happened to that point system, if we take a look at it, I'll just have to move out of this render to see it. If you take a look at what's happening in those points, you can see in that jitter node, as I move it, I'm going to take the solver. Yeah, I'm going to put the solver on. I'm going to move that. You're going to see the points moving very subtly there, so there's not much happening. So when you put it back into the shape, into rendered, you're going to see what we have. It's just making a decision to generate it right now. I mean, I try to get my script so nothing happens over 10 seconds. That's a little too long. But there you go. You get another multiple form that's been extruded. And it has a wonderful pattern. If you like symmetry, like I said, you've got to move away from symmetry if you really want to make some interesting things. I definitely have to put these in rendered if you want to see what they look like from top and side. But not bad patterns. I mean, pretty simple geometries. And once again, let's just throw it into another random 10% change on the gene pool. See if we can find another form that we kind of like playing with. But that's really what it is about, is finding things that probably your imagination would never come up with on their own. And I just think it's pretty exciting to get lost in this. And Turntable's always simple enough to kind of run. You can see how smooth that runs. So it's not too big a file. And as I go down here and check it out, I've got no problem with my scripts taking too long, 1.33 milliseconds, so that's not too bad. And would I start making objects like this? For what purpose? It's about gaining geometric and precise control over what's happening in a very customized way, not following too many other rules and utilizing these nodes. And as these nodes grow from a dozen to maybe 3 dozen in your script, excluding the parameters coming in, this is probably a 2 dozen script node, it's not that difficult to really come up with some beautiful things that, craft-based and working by your hands and working in metals and, molds and wax and plaster. You can see why I'm gravitating to this after 30 years of making work and 20 years casting metal. I can really make some decisions on the design end long before any fabrication has to take place. So thanks for watching.